All right, here's what we're going to do today. We're going to pick back up at the end of 6.1, talk about the exercises, and we will move on from there, probably get to the next section. I'll repeat my warning from last time. We are now at the part of the course where every class is important and every class builds on the previous classes. So to skip a class or to phone in a class would be a rather serious mistake. No, don't want that. See, we got the software working, we got the video camera working. That's quite nice. All right, today's session ID number 025577. And we will need it because we're going to do some translations. You'll remember last time we introduced you to propositional logic. Each capital letter represents a statement that can be true or false. The capital letter with the approximate sign, the tilde in front of it, is the negation of a truth claim, which is a way of saying that it is not the case. The dot or the asterisk is the and, which claims that both halves of the statement are true, and if only one half is true, then the and is actually false. I'm blowing through these quickly because we talked about this last time, so this is very much review. The little V or the wedge, that is an or. I told you that the weird thing about this or, unlike the normal English use of the word or, this is what's called an inclusive or, which really is probably best translated as at least one of these two claims is true. So the left side can be true and the or is true. The right side of the or can be true and the or will be true. Or both sides of the or can be true and the or is still correct. So in the normal use of English, or means only one of these two is true. In the logic use of the word or, both can be true. The arrow is a conditional statement. In your book, it's like a big horseshoe on its side. And this is a conditional statement, if then. The best way to think about the arrow statement is this. The arrow statement is true in every situation except one. The only thing that can make the arrow statement false is if the left side of the conditional is true, but the right side isn't true. So basically the default status of the arrow is true. If the right side is true, the arrow will be true. If the left side is false, the arrow statement will be true. The triple bar is basically a double arrow. It's basically the claim that the two sides of the statement will match. Either they're both true or they're both false. If one is true and one is false, then the claim of the triple bar is actually false, and the value of the triple bar is false. All right, and we'll get to multiple parentheses in time. All right, so let's start with some translations. Please translate the claim, not both A and B. Excellent. Yeah, we translate the negation first. Both tells us to open the parenthesis, and then we have an A and B. And all right, all of you got that. Great. Good, I'm not going too fast. Both A and either B or C. Good. The both tells us to open the first parenthesis. It's followed by an A. Then we have an and, which is the asterisk. This over here, the 2 is an or. So since the and comes first rather than the or, 3 is right rather than 2. Either tells us to open a second parenthesis, and then we get B or C, and then we close the proper number of parentheses. All right, good. We're on the right track. Either both A and B or C. All right, so now it's getting a little more difficult. The key to realize is this. Either tells us to open a parenthesis. What does both tell us to do? What does both tell us to do after either? Tells us to open a second parenthesis. Once you realize that, then it's not so hard. So you open the first parenthesis for either. You open a second parenthesis for both. Then we get A and B. Now I have to close the parenthesis. Can anyone tell me why I have to close the parenthesis here? Yeah, anytime you've got 2, you can never stick more than 2 letters in a parenthesis. So when you've got 2, you just know automatically you've got to close the parenthesis, because the whole point of the parentheses is to group no more than 2 together. So we got A and B, then we have or C. And since that's the end, we know we have an open parenthesis still, we automatically have to close it. So, so don't be fooled. We can give you multiple parenthesis indicators right at the beginning. All right, let's do some more. If A, then B or C. All right, for some reason, it doesn't want to display the answers. The correct answer here is C. We get if A. If tells us to open a parenthesis, put an A, and we're going to need an arrow. But because there's a comma right after the A, that indicates that the A is going to be separate from whatever we do with the B or C. And that makes the number 3 option correct rather than the number 1 option correct. Note that number 2 is never the right answer. And nothing that looks like number 2 will ever be correct. Anybody tell me why 2 is a non-starter? Right, because there are 3 letters grouped within one set of parentheses. You always have to have no more than 2 letters grouped within a parenthesis. If not A, then not either B or C. All right, let me do this for you. All right, if tells us to open a parenthesis. Not A tells us to put a negation right on an A. The if-then combination indicates that this is going to be an arrow. Then we have a not right after the then. So whatever occurs after the arrow needs a negation. Either tells us to open up a new parenthesis, and then we simply get a B or C. Then we need a parenthesis to close the B or C, and then there's nothing less, and we see we need a second end parenthesis. So the correct answer there was 3. If not A, then either not B or C. Good. All right. So if tells us to open a parenthesis, not A. The combination of the if and then communicate this will be an arrow conditional statement. Either tells us to open a new parenthesis, not B, and then we have or C, wedge C, close one parenthesis, close the second parenthesis. Now, I see some people put B. Now, one thing that's an easy way to rule out B is count the number of negations. The number of negation words in the English should match the number of approximate tilde signs, squiggly signs, in the logic. So option 2 here has 3 negations, but the English only has 2 negations. So since we're translating, you should match the number of negations. So for this to be number 2, we would need, if not A, then either not B or not C. We need that third not. I see there's not much inclination to choose 1 or 4. That's good. For 1 or 4 to be correct, you would need the negation word to occur before the if. You'd need something like, it's not the case that if. So you are correct in not being attracted to 1 or 4. Either A or B and C. Good. Now this one's a little trickier because you have to open 2 parentheses, but it only gave you 1 parenthesis opening word, the either. The way you know that you need the 2 parentheses up front is the comma keeps those 2 separate from the and C. So you know you have to divide up the 3 letters into a subgrouped parenthesis, and because the comma separates the C, that tells you that the A or B need the double parenthesis, the inmost parenthesis. Either A or B and C. Good. I guess that needs no explanation. Very good. If A, then not both, not B, and not C. Yes? We'll go back to it after we get the answer for this one. I think it was the placement of the comma. All right, so if A, well, that part's easy because I didn't give you any option other than open parenthesis A conditional. Then not tells you that you need a negation. Both tells you to open a parenthesis, not B, and not C. So the top option was right. Again, one of the best indicators is just match the number of negations to the number of negation signs in the translation. The if tells you to open a parenthesis, and the both also tells you to open the parenthesis. And the fact that you've got knots on either side of the both help you with that. Yes. When we're telling, if the instructions translate, the negation should always match. Because you have to, otherwise you fail to translate a negation. Was that your question too, sir? No. Would it negate all of it? Yeah. Okay, so you're saying there's a negation on the outside of the parenthesis. Does that imply a negation of all parentheses? If the negations are in the same place, right next to each other, you're correct that there are some rules of inference that let us, you can change the not, this isn't a translation, but an inference rule allows you to switch not both, not B, and not C to affirmative B or C. But that's not a translation, that's an inference. So you're kind of right, but not yet. Don't use that yet. Right now we're just on translate. All right, let me go back to the previous slide because we had a question about that. All right, so, oh yeah. So how did we know that we did the parentheses here? Well, we start with an either A, which tells us to open the first parenthesis. The or B and C, there's not a word that tells us to open a second parenthesis, but because there are 3 letters, you know you need a second parenthesis, and because of the placement of the comma, you know that it's the B and C that have to be sort of subgrouped in a deeper parenthesis. Which is good. It's good to ask those questions because we don't just want you to kind of guess right. We want you to understand the rule so you can use it later. All right, let's make it a little trickier. If you get an error message, then the disk is bad or it's a Mac disk. Some of Gensler's examples are a bit dated. I don't think I've used a floppy disk in over a decade. All right, if you get an error message, that part's easy. That's just E. Open parenthesis E. Then that indicates the use of the comma right after the message indicates that we're going to need another parenthesis. Then the disk is bad. B. or it's a Mac disk, B or M. And since you need an even number of parentheses at the end, you close the extra parenthesis. So number 1 is correct. Note that there are no negation words up there, so 3 should not be an option for you. And what helps you distinguish between option 1 and option 2 is the placement of the comma. The placement of the comma separates bad disk and Mac disk as what's going to be in the nested parenthesis. All right, now let's have some more fun. If I bring my digital camera, then if my batteries don't die, then I'll take pictures of my backpack trip and put the pictures on my website. All right. This is a hard one. And we will do ones this hard on the test, so we need to get used to these. All right, if I bring my digital camera, it tells us to open a parenthesis. B for bring my digital camera. The combination of the if and the then tell us we're going to need an arrow. The comma tells us the B is going to be separated. Then if, open another parenthesis, my batteries don't die, we need a negation because of the don't. And we don't want to reuse B because we already used B for bring. So batteries don't die is a not D here. Then I'll take pictures of my backpack trip and put the pictures on my website. All right, now here, here we just have to go with the natural flow of language. The pictures and the pictures of the backpack and putting them on the website, because they use that and together at the end, get grouped together. And then you just have to know that, just use logic. We've got 1, 2, 3 open parentheses. So we need to close all of our parentheses. So, yeah, that one was a bit harder. I think the biggest key to figuring this out was figure out where to put the negation. And realizing the negation is after the second parenthesis, not before. If you both don't exercise and eat too much, then you'll gain weight. Sad but true. Good. The if tells you to open one set of parentheses, and then the both tells you to open the second set of parentheses. You need a negation on exercise. You need an and. You need an eat too much. Then you need to close a parenthesis because you can never have more than two together. Plus, it gives you the comma. Then you will gain weight. Now, one thing that this multiple choice format is making it a little easier for you is this. You have to be careful, like with the Aristotelian syllogisms, you can only use each letter for one specific thing, and you have to use it consistently. So the last couple of examples have given you things like exercise and eat too much. And you need to know you can't use E for both of them. E can only mean one of the two, which is why I went with the X for exercise, because that's more distinctive. So if you've been if you have trouble, especially in the longer versions of these, it will be in part because you don't translate consistently. The statue isn't by either Cellini or Michelangelo. Yeah, this one is actually pretty easy. It's not one or the other. Pretty easy. If I don't have either $2 in exact change or a bus pass, I won't ride the bus. Yes, the 64% has it. All right, if tells us to open a parenthesis. If tells us to open the parenthesis. If I don't, tells us we need a negation for don't. Have either tells us to open a second parenthesis and that we're going to need an or. $2 in exact change, I used a T for that. Or a bus pass, B, then we have to close it automatically because you can never have more than two letters. Plus it gives us a nice comma. I won't ride the bus. Because we opened with an if, the implicit word there is a conditional then not are. So again, the good illustration, a lot of times the trick is figuring out where to stick the negation and figuring out the relationship between the negation and the scope of the negation in relationship to the parentheses. That's a lot of the battle here. Yes, ma'am. Nothing here is valid yet because these aren't arguments. We will get to full arguments, and we're going to teach more complex tools because these aren't syllogisms. You need there's more things you can do with these arguments, and you need more flexible tests. We'll be doing truth tables and truth assignment tests. It'll be fun. And again, if you're good at math, you actually will judge it to be fun. All you need to do is sort of think mechanically and mathematically. But we'll get there. Today, let's just get the translations right. If Michigan and Ohio play each other, then Michigan will win. this time of year, I'm inclined to interpret this as about basketball, but I assume this is actually about football. All right, now this one is actually, you all got this one wrong, and here's why. In that first phrase, if Michigan and Ohio play each other, is there going to be one truth value or two? It's only one truth value, because Michigan can't play each other without Ohio also playing each other. There's only one variable there. Although Gensler's intentionally phrased it in a way that you would be inclined to translate it as two. So because there's only one truth value up there, 4 is actually correct. Feel free to ask me questions about that, because I know that 4 is correct, because there's only one truth value in the top clause. Because it's not, the question isn't does Michigan play and Ohio play today, but just one, there's only one variable. Do they play each other? Right. I mean, it makes sense if you think about it, but it's not intuitive at first glance. And I don't want people blindsided by that, which is why we talk about them here during the exercises and not on the test. Either you went through both Dayton and Cincinnati, or you went through Louisville. Sounds like he's traveling on I-64. Good. Either tells you to open the first parenthesis, both tells you to open the second parenthesis. Then you have Dayton and Cincinnati together, and the comma tells us to close that. And then you switch to the or, went through Louisville. Very good. Everyone is male or female? All right, let me ask, how many truth claims are up there? Is it 1 or 2? It's just 1. The truth claim is that sexual identity is binary. That's the truth claim. And 19% of you realized that that was the claim up there. The only way to make this an or, you would have to add some words, would be something like the claim, everyone is male or everyone is female. That's the only way that you could get something like number 1. Yeah, and that would be kind of a strange claim, unless we're like, in a same-sex school or something. Everyone is either male. That's still just one truth claim. I mean, it'd be something like you really want to translate it as something more complicated than that. But the thing to look for up there is how many independent claims are there? And there's really only one. I think that's the last one in this set. Yeah, okay. Let me pause for a second, and we're not done. So we're gonna start the next section. How do we feel about the translator? I mean, let's bracket those two weird ones at the end, that everyone is male or female, and if Michigan or Ohio play each other. Other than those two, how do you guys feel about the translation? All right. Now look, this is, like I warned you with the syllogisms, this is one of those skills I need you to have down cold. I need you to be getting 95, 98% of these right. Because if you're getting 80% of these right, then you've already missed 20% of the problems, and we haven't even done anything with them yet. Because this is just step one, translate. We're gonna translate, then we're gonna test for validity, and then we're gonna do inferences. So this is just step one out of like 5 or more things we're gonna do with these claims. So if you just kind of got it, I mean, that's okay for today, but I want you to go back home and I want you to master this before we move on. Because if you don't master this, then your foundation is weak. And if your foundation is weak for this last month of class, this month, we're going to go some scary places in this next month. This is the easy stuff of the last month of class. So I want you to have this down cold. All right? All right, cool. All right, let's find the next. Let's find the next PowerPoint. There we go. Scared there for a minute. All right, the next thing we are going to learn today is called truth tables. And I'm just going to give you a brief introduction into these. Basically what a truth table is it is a mechanical tool for running through all possible truth combinations on a particular truth claim. So here, while the PowerPoint's trying to catch up to what I told you to do, let me show you how a truth table works. All right, well, that's useless. All right, here's how a truth table works. Let's say we've got a claim, a statement claim, P or Q. And what the truth table is designed to do is to tell us the value of the OR on all possible combinations of the P and the Q. So here's how we set it up. For each constituent statement, we need to put the constituent statement letter over here to the left. We need a division, and then we're going to use zeros and ones. Zeros means false, ones means true. Basically, we're just doing binary. This is like how computers think. So the hardest part is, when learning how to set these things up, is setting it up so that you run through all possible combinations of true and false for P and Q. In my opinion, the easiest way to remember is the innermost letter, you alternate false and true. And then for each subsequent letter, you double the number of falses and double the numbers of trues. So if we had a third letter, which we don't have here, it would be 4 falses followed by 4 trues. All right, but we don't have this. Right now we're doing things that are really simple. All right, so if I want to know when the claim P or Q is true, we run through the 4 possible combinations of P and Q. The first one is when both are zeros, which means both sides are false. What is the value of OR when both sides of the OR is false? The value is false. All right, what if the P is false, but the Q is true? What is the value of OR? Well, the value will be true because the OR is true anytime either side is true. All right, what if the left side is true? What if the P is true, but the Q is false? Then the value of the OR will be true. And what if both sides of the OR are true? Then the OR is true, which is what I warned you about. What's weird about the OR is that this last one sounds wrong to us because of the normal common language use of the word OR. But for us, that's the way it's going to work. All right, so let's show you a few of these. All right, so here are some simple truth tables. Truth tables are going to be used to illustrate all the various possible values of a well-formed formula, and how the value of the sentence changes when the different constituent parts change. All right, and this is the AND truth table. The AND truth table, the AND is false in every situation except one. The default value of the AND is basically false. The only time it's true is when both sides of the AND are true. In contrast, here's the truth table I just showed you. For the OR truth table, the OR truth table is true in 3 out of the 4 situations. It is only false when both sides of the OR are false. And here's the one that people struggle with the most, the if-then truth table. And the way I tell people to remember this is that the arrow is true in every situation except when the left side is true, but the right side is false. And again, think of if someone has made you a promise, but it's a conditional promise. If such and such happens, then I will do this. If you get straight A's, I will buy you a car. Let's say your parents tell you that. If you get straight A's, I will buy you a car. Well, under what situations is the promise true? Well, look at the first 2 situations where there's zeros on the left side. The left side is where you failed to get straight A's. If you get straight A's and I don't buy you a car, was my promise true? Presumably. I mean, you don't really know what I would have done, but the default value for this is true. What if you've got a super generous parents, you failed to get straight A's, but I got you the car anyway? That conditional was like extra true. All right, the only time I'm a liar is this combination number 3. If you get the straight A's, but guess what happens? No car. That would be the only time I failed to keep my promise. And then, of course, the 4th situation, if you get the straight A's, and if I buy you the car, then the conditional is true. The promise has been kept. Yes, ma'am. The second one again. Second one is great. So I promised that if you get straight A's, I will buy you a car. So the second one, the 0 on the left and the 1 on the right, is you didn't get straight A's. But you know what? I got you the car anyway. So was the promise true? Now, maybe you think the promise was false because I bought you the car anyway. You think that outcome should change. But I didn't say I will only get you a car if you get straight A's. I said, if you get straight A's, I'll get you the car. I didn't really tell you what will happen if you don't get the straight A's. Now, I encourage you, don't talk to people in real life that way. That will freak them out and make them think you're being subtle or dishonest. And frankly, you would be being subtle. What you would be doing is splitting hairs the way we do in logic class. Because that's not a normal way of speaking. But if you want to be technically correct, which is the best kind of correct in logic class, I didn't tell you what would happen if you didn't get straight A's. I told you what would happen if you did. All right, on that happy note, welcome back. Hope you had a good spring break. I don't know, I'm still exhausted. Hopefully we'll get through the semester. Good luck to you all.